We live in a world we believe we understand. We are taught from a young age about the cycles of nature, the geology of our planet, and the biological kingdoms that define life. We learn that a tree is a perennial plant with an elongated stem or trunk supporting branches and leaves. We see them in our parks, our forests, our backyards. They provide shade, oxygen, and a sense of enduring, quiet life. This is a fundamental truth, a bedrock of our understanding of the natural world. But what if this fundamental truth is, in fact, a profound misunderstanding? What if the things we call trees are merely insignificant shrubs, a pale imitation of a former, colossal reality? And what if the real trees, the true giants of a forgotten epoch, are still standing all around us, but we have been taught to call them mountains? This is the premise of a theory so audacious, so contrary to established science, that it forces us to re-examine the very ground beneath our feet. The theory posits that our planet was once home to a forest of unimaginable scale, populated by trees that reached into the upper atmosphere. These were not the carbon-based, relatively fragile organisms we know today. They were something else entirely, colossal, silicon-based life forms, whose petrified remains now constitute some of the most famous geological formations on Earth. What we call geology, the theory suggests, is in large part the forensic study of a global, cataclysmic deforestation event. Let us begin our investigation in Wyoming, USA, at a place of stark and mysterious beauty, Devil's Tower. This monolithic formation rises dramatically from the surrounding prairie, a fluted column of rock stretching 386 meters into the sky. The official geological explanation is that Devil's Tower is an igneous intrusion, specifically a laccolith, molten magma, they say, pushed up into sedimentary rock layers and then cooled, crystallizing into the distinctive hexagonal columns through a process of contraction. The surrounding softer rock then eroded away over millions of years, leaving the harder core exposed. This is the story told in every textbook. But we must ask ourselves, does it truly look like the result of a random volcanic process? Look closer. The top of Devil's Tower is remarkably flat, almost perfectly level, as if it were sliced clean by an immense blade. The sides are not a chaotic jumble of cold rock, but are composed of thousands of near-perfect hexagonal columns, running vertically with incredible precision. It looks less like a geological accident and more like a bundle of enormous, fibrous strands. Now take a piece of wood from a modern tree and place it under a microscope. You will see a cellular structure, a network of vascular tissues, often arranged in a hexagonal pattern. The visual parallel between the microscopic structure of a plant and the macroscopic structure of Devil's Tower is uncanny, even unsettling. The theory proposes a simpler, more direct explanation. Devil's Tower is not a laccolith. It is the petrified stump of a single, gigantic, silicon-based tree. The flat top is where it was broken or cut, and the hexagonal columns are its fossilized vascular bundles. The Native American legends of the region, which speak of a great tree that saved people from a giant bear, whose claws scraped the sides of the rock, suddenly seem less like myth and more like a distorted, ancestral memory of a biological reality. If Devil's Tower is a single stump, then where was the rest of the forest? The theory invites us to lift our gaze and see the pattern across the globe, travel to the desert landscapes of the American Southwest, to Monument Valley or the mesas of Arizona. Mainstream geology tells us these are buttes and mesas, remnants of erosion, hard rock layers that resisted the wind and water that stripped away the softer surrounding material. But viewed through the lens of this new theory, they are transformed. They are not random mesas. They are the vast, weathered stumps of countless other titanic trees. Their flat tops and sheer cliffs are not the work of erosion, but the signature of a planet-wide felling. The Grand Canyon itself, that immense scar upon the earth, is recontextualized. The official narrative claims the Colorado River, a relatively small ribbon of water, carved this colossal chasm over millions of years. The theory offers a more shocking alternative. The Grand Canyon is not a product of natural erosion. It is a quarry, a massive, open-pit mine where the resources of this ancient, giant world were harvested on a scale we can barely comprehend. The sheer volume of material removed simply does not align with the erosive power of the river that flows through it today. The evidence for this ancient world of giants is not confined to stumps. A tree, after all, also has roots. Let us journey across the Atlantic to the coast of northern Ireland, to the Giant's Causeway. Here, some 40,000 interlocking basalt columns descend from the cliff face and disappear into the sea. The geological explanation is similar to that for Devil's Tower, a volcanic fissure eruption, with the lava cooling rapidly as it met the sea, forming the same hexagonal cracks. Across the water, on the Scottish island of Staffa, the sea cave known as Fingal's Cave displays the exact same phenomenon. Geologists explain this by saying they were once part of the same ancient lava flow. But again, the theory presents a different picture. These are not cold lava flows. They are the petrified root systems of another of these colossal silicon trees. The mathematical precision, the organic seeming pattern of the columns speaks not of chaotic volcanism, but of the biological structure of a root network, fossilized for all time. To understand how such a thing could be possible, we must fundamentally reconsider the biology of these ancient trees. The theory posits they were not carbon-based. Carbon life is fragile, it decays, it burns. Our trees live for decades or centuries, perhaps a few millennia, and then return to the soil. Silicon, carbon's neighbor on the periodic table, offers a different possibility. A silicon-based life form could, theoretically, be far more durable, more crystalline in its structure. If these trees were silicon-based, their petrification would not be a process of mineral replacement over eons, but a more direct transformation. When they died or were destroyed, they would not rot. They would simply turn to stone, as their fundamental biology was already stone-like. Silicon dioxide, or quartz, is one of most abundant compounds in the Earth's crust. What if this abundance is not merely geological, but biological in origin? What if the vast deserts of our world, the endless sands of the Sahara, are not just eroded rock, but the sawdust of this ancient, giant forest? This hypothesis paints a picture of a prehistoric Earth that is utterly alien to our own. A world with a different atmosphere, perhaps denser, with higher oxygen content, allowing for gigantism in all life forms. This connects to the fossil record, which shows us periods where insects were the size of birds and ferns grew to the size of modern trees. In this world, the silicon trees were not just passive flora, they were the planet's energy grid. Quartz is piezoelectric, meaning it generates an electric charge in response to applied mechanical stress. It is also pyroelectric, generating a voltage when heated or cooled. These giant, crystalline trees, reaching from the geothermally active crust to the electrically charged ionosphere, could have functioned as immense energy conductors, capacitors, and regulators, powering a global ecosystem or even a civilization of which we have no record. The myth of a world tree, or Axis Mundi, found in countless ancient cultures, Yggdrasil in Norse mythology, the tree of life in the Bible. The Ceiba tree of the Maya could be the faint cultural echo of this planetary energy system. What, then, could have brought such a world to an end? The evidence points to a catastrophe of unimaginable violence. The trees were not just felled, they were shattered, pulverized. The scale of the destruction suggests something beyond any natural disaster we know. Was it a war? A conflict between beings of immense power, using weapons that could slice the tops off mountains and turn entire forests to dust? Or was it a cosmic event, a meteor shower of unprecedented intensity? Or a dramatic shift in the planet's atmosphere or magnetic field that caused a silicon-based biosphere to collapse and crystallize? The theory suggests that after this great reset, the world we know began to emerge from the ruins, The carbon-based life that had perhaps existed in the shadows or which arrived from elsewhere began to flourish in the new environment. The small, fast-growing plants we call trees are a new form of life, adapted to a world with a thinner atmosphere and a broken energy grid. They are, in essence, opportunistic weeds growing on the graveyard of a far grander world. And what of the cover-up? Why is this knowledge not mainstream? The theory ventures into conspiratorial territory here, suggesting that the very discipline of modern geology was established in the 18th and 19th centuries with a specific, perhaps unconscious purpose: to create a narrative that would explain away these colossal ruins as natural formations. It was easier, safer, to believe in slow, uniformitarian processes of erosion and volcanism over millions of years than to confront the reality of a violent, forgotten history and a world of giants. We have been conditioned to see mountains as just mountains, deserts as just deserts, and strange rock formations as geological quirks. We have been taught to dismiss the myths of our ancestors as fanciful stories, rather than the corrupted historical records they might actually be. This theory is, of course, shocking. It contradicts nearly everything we have been taught. It lacks the peer-reviewed papers and the academic consensus that are the hallmarks of accepted science. It is easy to dismiss as fantasy, as a wild tale spun from coincidental appearances and a distrust of authority. Geologists can and do offer detailed, complex explanations for every one of these formations, from the chemical composition of the rock to the physics of magma cooling. And yet, the questions linger. Can slow erosion by a small river truly carve a canyon a mile deep and 277 miles long? Do random cooling processes consistently produce tens of thousands of near-perfect hexagons? Why do so many disparate cultures, separated by oceans and millennia, all share a core myth of a giant tree at the center of the world? Why do these mountains look so much like stumps? Perhaps the truth is not a matter of choosing between two competing explanations, but of expanding our capacity for wonder. The theory that there are no trees on Earth, or rather, that the true trees are mistaken for mountains, is a powerful thought experiment. It acts as a key, unlocking a different way of seeing the world. It encourages us to look at a landscape not as a static, finished product, but as a crime scene or ruin, a remnant of a history far stranger and more magnificent than we have ever imagined. The next time you stand before a great mesa, a towering butte, or a strange, columnar rock formation, suspend your disbelief for a moment. Ignore the textbook explanation. Instead, see it for what it might be: the tombstone of a giant, the fossilized remnant of a world that was, a world of silicon and sky-high forests. You may find that the world no longer looks the same. The rocks themselves may begin to tell a different story, as silent, epic testimony to a paradise lost, hidden in plain sight.